So friends, in this video we are going to look at gas laws, and those gas laws include the Chelsea's law, the Boyle's law, and the Avogadro's law. Yeah, for Chelsea's law, states that the volume of a fixed mass of a gas is directly proportional to its absolute temperature at constant pressure and number of moles or amount. So this one simply it's an indication that the volume of a fixed mass of a gas is directly proportional to its absolute temperature at constant pressure and number of moles in. So that means V will be equaling to constant T. So to make constant the subject, we shall have V out of T equaling to K. So if there is a change, so initially before the change, we should always be having temperature volume 1 over temperature 1. But in case of a change, this one will be equaling to V2 T2. The gas can undergo different changes up to infinity. The changes can be up to infinity. So graphically, this is temperature, this is volume. So the graph of this chart is zero. It is that as temperature increases, pressure increases. Pressure also does what? Increases. So at any point, as temperature increases, as volume increases, temperature also increases. So that means there is a direct proportionation, in that when one decreases, the other one decreases. When one increases, the other one also increases. That is all about Chelsea's law. But then when we go to Boyle's law, for it states that the volume of a fixed mass of a gas is inversely proportional to its pressure at constant temperature and number of moles or amount of a gas. So to derive this expression, it is saying that the volume of a fixed mass of a gas is inversely proportional to its pressure at constant temperature and amount. So that means V will be equaling to K out of P. So to make K the subject of the formula, we shall have V out of P equaling to K. So this one, sorry, I beg your pardon. If you make K the subject of the formula, we shall cross multiply. So that one is wrong. That one will be K will be equaling to VP. So before in the initial stages of the gas, V1, P1, yeah. Then after a change, this one will be going to V2, P2. This one is initial. Then these ones are undergoing different changes. The change can increase up to infinity. Yes. Graphically, if you plot this one on graph, this is pressure, this is volume. So these ones have got a negative gradient in that at low volume, pressure is high. Then at very low volume, pressure is very low. So when you increase volume, pressure decreases. When you increase volume, pressure decreases. When you decrease volume, pressure increases. So when this one increases, this one decreases. When this one increases, this one decreases. So and for Avogadro's law, this one relates the number of moles and the volume. So there is a direct proportionation of of number of moles of a gas and the volume of that very gas. So it states that the at constant pressure, and temperature, the volume of the fixed mass of a gas is directly proportional to the number of moles. So that means V will be equaling to Kn. So if you make K the subject, it will be K equaling to V out of N. So before I change V1 out of N1, that is the initial stage of the gas. But then if you make changes within the variables, then it will be equaling to V2 after the change divided by N2, because the number of moles also must increase for this principle. So the changes can go up to infinity. So here graphically, so these are the number of moles of a gas in bracket N represented by N. So this is the volume. So the graph has got a positive gradient. So here it is a direct proportionation in that when you increase volume, the number of moles also increase, and as you decrease the number of moles, the volume also increases. So there is a direct proportionation. Thank you for being good listeners, and thank you. So subscribe to this account to get more videos about the different expressions of chemistry. Thank you.